What's up, nerds? Harbinger here, doing a two-part video. I could either make this like a half-hour video and bore everyone to death, or I could make this two 15-minute videos and bore everyone to death twice. So double the videos, double the ad revenue. Am I right? Anyway, I'm going to explore Python loops in addition to AP Computer Science Principles kind of notation loops. They're done in a different way. And what I really wanted to do was do an entire video on Python loops and the different kinds of Python loops, and then do the second video using the principles syntax stuff. But instead, I'm going to split it in terms of all one problem, the same problem pretty much, done different ways. We're going to do a factorial. And then the second video is going to focus on a similar kind of dynamic in the sense that we're going to do similar things, but done in a variety of ways. So what I'm going to do first is I'm going to do a basic loop problem. When you first learn loops in programming, you learn to do a while loop, learn to do a for loop, and often they are really similar. There are subtle differences, but I'm going to show you the same kind of problem done in different ways. So I'm going to get to this exam reference sheet in a second, but not yet. I am going to go to Trinket, and I am going to save all this stuff for now. We did use Replit before, but it was having some problems last week. And right now, I'm going to use trinket.io/Python. It seems to be pretty good in terms of a compiler. I know the exact dimensions of the screen, I think. So that helps when it comes to drawing stuff. But for now, I'm not going to really focus on turtle stuff. If you've been following along in class and you've noticed we've done some really good turtle graphics, that's great. But right now, I'm focusing on the pure Python aspect of it. I'm not drawing anything. I'm going to make variables and control structures in here, and it's going to print stuff out down here, and that's great, but I'm not going to draw anything pretty. So what I am going to do now is I'm going to move this up a little bit, and that way I can have an editor, and we'll see how it goes. So first thing we got to do is take credit for our brilliance. Sometimes it helps if you spell your name correctly, but, you know, can't ask for everything, right? If you know what a factorial is, that's great. If you don't, that's cool too. Here goes. Factorial program. Now I'm going to do an example like 5 factorial because I know that's 120. I know it's 120 because it's 5 times 4 times 3 times 2 times 1. Alternatively, some people prefer 5 factorial as 1 times 2 times 3 times 4 times 5. That's a big help too. Sometimes people like to count up. For the cool kids out there, 5 factorial is also 5 times 4 factorial. Oh wait, that's like weird, right? Oh well, here goes. I do need a variable though that represents the number that I'm going to be factorialing for now. I don't know if factorialing is a verb, but you know, people make up words all the time, and I've heard of worse things. So for now, I'm going to call it num because I don't know what else to call it, and I'm going to set it equal to 5. That seems to be okay. I also know that I'm going to need a variable that holds on to the product, right? First, we're going to set it equal to 1, and the point is to be 1 times 2 times 3 times 4 times 5, or the opposite, 5 times 4 times 3 times 2 times 1. And hopefully at the end, it's going to say 120. Ultimately, I'm printing the value of prod, right? So I'm going to call it prod, and I'm going to set it equal to 1, and its job is to remember things and remember the product. So for now, I'd like to do this different ways. So for now, what I'm going to do is I'm going to say for x in range. And again, x is a variable that is like a step variable. It's going to start at a spot. It's going to end at a spot. And I'm going to send it from 1 to 5. And I hope that some of you are howling right now because you see there's an error in that. What I'm about to do is on purpose. All right. It's a loop consequence. So I'm going to indent, right? Anything that's indented right now. I keep like doing stuff with my hands and you can't see it. Sorry. Anything that's indented right now is a consequence of the loop. It's part of the iterative process. If you want to impress your friends, drop the word iterative process. It just means something that happens over and over and over and over again. So you learned something today. Maybe. Prod times equals num. Could that be a thing? Maybe. Do we really want to do it that way? I don't know. Let's find out. So I can't do that because then num never changes. So what I really have to do is just subtract. that every time, and maybe this works, maybe it doesn't. Some of you are like, wait, there's an easier way. I know, I'm doing it that way in a second. I'm showing you the way that normally people do it the first time they have to do this. At the very end, I'm going to print prod, and we'll see if it works. Hey, 120! Woo! So what did it do? 1 times 2 times 3 times 4 times 5. Maybe, we hope. This 4x in range business in here. If you remember the other loop video, or what maybe we talked about in class, if I saw you, x's values that iterate are 1, 2, 3, and 4. So what happened? Prod multiplied itself by 5. Then it multiplied itself by 4, then by 3, then by 2, then by 1. That's awesome. If you actually want to see it happen, we could just indent prod like that, and you can see it climb. You can see the 5 times 4 to 20, times 3, times 2. Maybe you're thinking, wait, what happens about 1? Remember, it doesn't actually include the last step. If I wanted to run 5 times, 1, 2, 3, 4, and 5, I actually have to bump the terminal value by 1. And you get to see the 120 happen twice, and that's because you're multiplying it by 1. If I bump print out of the loop, it's just 120. So my hope right now is some people are saying, wait, shouldn't there be like a, I wish I could highlight stuff. Should we just use the value of x? Those are my veterans talking, or just my insightful people. Boom. It didn't do anything. It's still 120. That's right. It didn't do anything different. Functionality-wise, it's the same thing. I can show you what happens in here. This time it climbs up. 1 times 2, that's times 3, times 4, times 5. So I think this works really well. Right now I'm using the values of prod, and I think some people are now kind of upset that I'm not using num. Right? Num should really represent the value that I'm trying to find the factorial of. Sorry for being grammatically not okay right there. So what I'm going to do is I'm going to change this to num plus 1. That way, if I ever wanted to find the factorial of 10 or something like that, I wouldn't have to change this up here and this down here. That's not cool. Nothing changed. Good. So now if I want to find the factorial of 8 or something like that, that happens. Okay, what if I want to find the factorial of 15 or something like that? It runs 15 times. That's fantastic. And it's getting really big because, 1 times 2 times 3 times 4 times 5 times 6 times all the way up to times 14 times 15 gets huge. Maybe you're wondering, is there a limit? My Java people right now are probably freaking out because we exceeded the integer upper limit. My response is going to be a shrug and saying, welcome to Python. Because that's 30 factorial. That's gigantic. It's funny because 50 factorial gets huge fast, but I'm not really going to just mess around with this for fun. I mean, do I really care about 30 factorial versus 50 factorial? No. It was pretty fast, though, if you saw that speed. So I do have some people probably who are like, wait, he said you can go backwards. You can. Remember, the Python step variable goes third, so we can count down. So instead of 50, I'm going to go back to 5. And if it works, and it does, 5 times 4 times 3 times 2, and you'll note that 1 isn't included in it because the last value in the loop, that would be the second argument right here, whatever's right here, doesn't get included. It's like 5, then 4, then 3, then 2, and it's like, oh, I hit 1, I don't have to do what's in the loop. So, you could always say 0 if you wanted to include the 1, but it doesn't really matter too much. So I counted, this is counting down, the previous one was counting up. Okay, how about a different loop, right? How about we do a while loop? So while loop will be our second to last loop because, I don't want to take too long in this video. And a while loop is similar to a for loop in that it's going to do something over and over and over and over. Except whereas a for loop runs a particular number of times, it runs on, hey, you will run from this number to this number. It is a set number of iterations. Unlike a while loop, whereas a while loop says, hey, I'm going to run for as long as this statement is true, maybe forever. A while, I don't even know what. Num is greater than equal to 1. Note the colon, right? That's like saying, hey, while. It doesn't really end a thought. So while this is true, do the following. Prod times equals num. And what that does is right now, hey, is 5 greater than or equal to 1? Yes, it is. So we are going to multiply 5 into the value of prod and store it in prod. So 1 times 5 is 5. Prod currently holds 5. The difference between the while loop and the for loop, though, is whereas a for loop automatically increments, 1, then 2, then 3, then 4, then 5, it changes for you. And we just reset it a second ago in terms of the for loop. We changed it to count down with that little -1 at the end. While doesn't provide that functionality. You have to tell while what to change by. If I don't, this is called an infinite loop. Since 5 is always greater than or equal to 1, and the value of num isn't changing, it's just going to constantly multiply 5 in over and over and over. You're going to see increasing powers of 5. Heck, I'll show. If this crashes everything, this is your fault. Kidding. So right now, I really thought that would have stopped it. Oh, stop button. There we go. You're seeing powers of 5 go crazy, right? 5, 25, 125, 625. It's just growing like crazy, and it blew up really fast. That's because it doesn't drop ever. So what I'm going to do now is that looks like fun, and everyone tries it once, and that's cool and all, but let's do this. I dropped num by 1. So it goes 5 times 4, because num is now 4. And after it subtracts by 1, it decrements. Num is now 3, so the next time through, we're like, oh, is 3 greater than or equal to 1? Yeah, it is. So we multiply 3 in to prod. It's now 60. Num drops by 1 to 2. Is 2 greater than or equal to 1? Yes. So we multiply 2 into prod. It's now 120. And num drops by 1 to 1. Is 1 greater than or equal to 1? Yes, it is. So we multiply 1 into prod. It drops to 0. Is 0 greater than or equal to 1? It's not. So we stop. If you wanted, you could actually print prod and also print num. And that way you can kind of verify the values as you go through. You just don't have to. Okay, last thing. I mean, some people are saying right now, wait, you iterated 1 time too many. That's inefficient. Yeah. Oh, well. You could always take out the equal sign as long as you're involving multiplying by 1. If you leave it in, though, it doesn't change the functionality. It does loop 1 more time, and you're just multiplying by 1, and who cares? But it will matter on other programming problems, right? It matters if you are ending at something other than that. Sometimes you do care about greater than versus greater than equal to. So just be aware, please, that loop boundaries are a big deal, just like infinite loops are a big deal. Just keep that in mind. So last thing, when you get to the exam, the programming language isn't Python. In fact, the computer science principles exam is language agnostic. It doesn't adhere to certain language syntax. It's not like it's in Java. It's not in Python. It's not in Ruby or C or anything like that. It'd be nice, but they want you to understand that programming is more than just a particular language. Python is fantastic to learn on, and it works well with turtle graphics, but it doesn't mean that everyone in the country right now is using Python in order to learn computer science principles. Some are using Java, some are using C. I don't mean to like blaspheme here, but that's not the best way to learn programming if you're just trying to get your feet wet. Some people are using Scratch. I like Scratch to learn on. Some people right now are going to downvote me. Bring it. And then some people are even using like App Inventor, and they're just making apps and learning programming that way. But in order to ask programming questions, they had to invent their own syntax. So if you ever look at the computer science principles course and exam description found on College Board, you can see right now that URL. And if you can't, then, hey, I just typed in AP Computer Science Principles course description, a resource guide. This is really far down. You can see the track bar on the side. We are on page 214 out of 260. They give you this on the test. That's really nice. The problem is, since it's not language specific, not a lot of teachers spend a lot of time teaching this syntax. I'm going to go over it a little bit. I'm going to translate one of the problems we just did into this syntax. I am going to use it to ask questions on quizzes throughout the year, just so you don't get to the test and you're like, I don't know what this arrow means. So Looking right here, this is early on. This is before loops. A arrow expression, arrows pointing to the left. That just means, hey, whatever's happening over here on the right-hand side of things, we're going to store it in a variable called a. In Python, this is equivalent to like a equals whatever, a equals 3, a equals b plus 7, or something like that. Additionally, we also have like a plus equals 10. That's a thing. Here it would say something like a left arrow, a plus 10. So just be aware that that syntax is different. When I type in computer science principles, quizzes, and things like that, I'm going to be using that syntax. A with a left arrow, X with a left arrow, num of tries with a left arrow. It's better than this. They're also going to use block notation. So it looks like Scratch programming, if you've seen that before. If you haven't, it just lets them put blocks together so you can visually see what's in a loop or what maybe is a conditional or something like that. I'm not doing that. This is really hard to type. This right here. I don't have a text editor in like Word or Google Drive that puts a little rounded rectangle over things I want it to really easily. This, though, I can get the ASCII for the left arrow pretty quickly. Heck, it's probably less than hyphen hyphen. I guess we'll find out when I start typing stuff. And I'm going to use Notepad anyway, so it's not going to show up. Because I just like Notepad. It doesn't format stuff for me. I like it like that. Hey, when we show text, it's going to say display. In Python, we have print. Print hello. In Java, it's system.out.println. You know, in C or C++, it's C out, arrow, arrow, hello. There's a lot of ways to print stuff. And for now, in the computer science principles notation, they use display. I like that. I kind of prefer print, but, you know, what are you going to do? Sometimes they're going to ask you for input. They're going to have an input block. We haven't done that in Python yet. Right now, we're just assigning things. You can see these 4 variable operations. I hope you know how to add, subtract, multiply, and divide. I'm not talking about those right now. They do have decimals, though, for my Java people. Heads up, int divided by an int is a double. Just get ready. If you don't know what I'm talking about right now, it's okay. You don't have to. Wait till Java. Mod, we haven't done yet, kind of, but we will. And in Python, you saw random.randint with a range. In the computer science principles notation, they just say random a comma b. I love this. This is so much easier, right? Random 1 comma 6 is like a roll of a die. Man, that's smooth. Okay, conditional things are fun, but we're not doing them yet. We kind of are in a way, but right now I'm kind of shrugging and saying I expect you to know how to read the word if. And if you don't worry, we'll get to it soon. These, though, are important. So you actually know the distinction now. Repeat n times is the same thing as for x in range, letter n, or something like that. For x in range 12, for x in range 13, comma 0, comma negative 1. Right? That's a thing. In their notation, it looks like they're just going to repeat something a certain amount of times. And sometimes they're going to use n in their expressions, and that's like a variable number of things happening. I'll show you what I mean in a little bit. And the one below it says repeat until condition. That's like a while loop. The first one definitely iterates a certain number of times. You will perform this action this many times. Unlike the bottom one where it's like, hey, you're going to do this thing until this other thing happens, and then, you know, we'll deal with it. That's it for now in this notation. I'm going to do the factorial problem in this notation, and then I'm done. Hey, Notepad. It's like an old friend. So I think I'm not going to use, do I really have to use caps lock? I guess I will. Repeat. And I'm going to store something above it just so I can make sure you know that there's notation like that. I'm going to call it like num, I guess. And there's my left arrow because I'm fancy like that. 5. I'm going to store 5 in the variable num. And I'm going to repeat this num times. That's better. So far to go. I've never really written code like this before, so I'm kind of having fun exploring a new dynamic. The idea hasn't changed at all. It's just the way we type it. And that's what programming really is in its heart. It's not, hey, I can program in this language, but not this one. Yeah, but the ideas are the same no matter what. Once you're good at a language, you can just pick up another one relatively easily. The hard part is getting the ideas down first. As soon as you understand loops, like Obi-Wan once said, you've taken your first steps into a much larger world. So welcome to the larger world. Like Morpheus said, welcome to the real world. Dude, I'm dropping like 2 nerd references. all in less than 20 seconds. Like Ice Cube said, today was a good day. Okay, what I do need is a variable up top, though, to hold the product. You can see I just slipped and typed an equal sign because I don't even think I thought about it. I just had to have it. So repeat num times. That means I'm going to do prod times equals. Oh, snap, there is no times equals, right? You saw all the stuff. So I have to be careful. Oh, shoot, here I am typing an equal sign again. Old habits die hard and all that, right? So, like that. It's not like Python where I care about the boundary. Is 5 included or is it not? Do we go up to but not include it? It's assumed in computer science principles notation that it's included. So let's talk about what this thing does before we add one more thing. That's going to get like a Steve Jobs reference there. Oh, and one more thing. So I declared a variable named prod, and I stored the number 1 in it. And then I declared a variable named num, and I stored the number 5 in it. And I'm saying, hey, whatever the value of num is, let's do it that many times. I'm going to take whatever's in prod and multiply it by num, and we're going to store the result in prod. And so right now, it's going to multiply 5 over and over and over again. Man, I wish I was smart sometimes. I should probably have another variable that handles that. Otherwise, it's going to be like a powers of 5 thing all over again. That's better. So I could do like step plus 1. Woo! Okay, let's talk it out loud now. Hey, 1 is in prod, 5 is in num, 1 is in step. Hey, let's repeat this 5 times for now. Whatever's in prod, which is currently 1, times step, which is 1. 1 times 1 gets stored in prod, and step jumps to 2. 2 gets multiplied by 1, stored in prod. So it's going to repeat, and I'm happy. Ultimately, we go through all 5 times, 1 and 2 and 3 and 4 and 5, and then I'm fine. You could have instead done something like, I don't know what their comment notation is, and I don't really feel like flipping back. Repeat until, it's going to look something like that. Then I could have the same body in my loop. That would work also. It's the same thing. I actually really like how they're similar, but there's some subtle differences. Hey, repeat until they're equal, right? 1, then 2, then 3, then 4, then 5. Hey, we got that value. So we stop, and we're done. So what we could have done before is we could have put the print, although I think they called it display, if I'm not mistaken, display prod, and that's going to print the current product 5 times. If I unindented it, sorry, I have to sneeze something wicked. If I unindented it, that's just going to print it 1 time, just the final value. So I'm going to leave it like this because I like that more. The screen doesn't get as messy. If I do have bugs in my program, if it's not working like I want it to, I tend to bump this guy back. It's called like tracing. You know, you can put variables inside loops and things like that with some displays or prints, and that way you can see what's happening on the screen. But that's just me being dorky. Now that's me being efficient. Now some of you were thinking, wait, but how do you know it works? Like, there's no compiler, right? There's no development environment. So there's no way for me to actually run this code and see that it works, right? This is supposed to be language independent. We don't know what language it's in. It's just this made up thing that allows us to express our ideas. So I can't really run it as much as I can talk it out, and that's good. So I like it that there's no place to just plug this in and go. But I kind of wince a little bit because I'm like, now I got to think about things when I'm answering questions. Yeah, we got to think about things when we answer questions. So again, that's cool like this. I'm not going to compile it and run it because I can't. Someone probably built something somewhere. I'm not dealing with that right now. So for now, that's all the different loop structures in the different languages. Catch me on episode 2, Attack of the Clones. I mean, whatever. Next video. I need that ad revenue. Harbinger out.